I'm Mr. Klingler, and today we're going to talk about Lenz's law. Lenz's law is used to find the direction of the induced current in a conducting loop. If you recall, Faraday's law found the EMF, or the voltage generated by a magnetic field. This will find out the direction of the current induced. The law itself is pretty simple. The induced current will be created such that it opposes the change in magnetic flux. All right, seems pretty simple. Opposes is key here. The reason it opposes is because, as it turns out, we need to conserve energy. So this law is really a restatement of conservation of energy. All right, let's figure out how to apply this. First, you find the direction of the original magnetic field. Then you ask yourself, is the magnetic field getting stronger or weaker? How do we oppose that change in magnetic field? And then use the right-hand rule to determine the direction of the current that is created to generate the weakening or strengthening of the field. Notice this is going to be all in terms of field. Let's look at an example. Okay, I have a metal bar that is free to slide along some conducting rails. There's a resistor connecting the rails. There's a magnetic field pointing into the board, and I slide this metal bar along these rails. What's the direction of the induced current in the resistor? Well, clearly there's a change in flux. And if we really wanted to know this, we might be able to use right-hand rule force on positive charges and make an estimate. But let's try using Lenz's law. First, what's the direction of the original magnetic field? The original magnetic field is going into the board. Is that original magnetic field getting stronger or weaker? Well, as I expand the loop, I have more and more field lines passing through it. So the flux keeps getting stronger and stronger. I'm going to try to oppose that change. Well, how would I oppose more field lines going in? I would need more field lines going out. So I'm going to oppose it by field lines out. All right. I need to have field lines out. The induced current is what's going to generate those field lines. So my thumb points this way, because that's the direction of the induced magnetic field. I curl my hand by a loop rule, and I realize the induced current must be directed this way in order to oppose the change of flux. Therefore, the current in this resistor is going down. Let's try another one. So imagine I have a conducting loop with magnetic field coming out of the board. The magnetic field over time is getting stronger. What's the direction of the current in this resistor? Okay, there's clearly a change of flux, so current will be induced. What's the original direction of B? B is out of the board, and as stated, getting stronger. Now, how do I oppose this change? Well, I have more and more field lines going out. To oppose that change, I need more and more field lines going in. Using the right-hand rule, I need to generate X's. Thumb points in the direction of the magnetic field in the center of my loop. I curl my fingers around. It appears that the current will be going that way in the resistor. Let's look at one final example. What's the direction of the induced current in this resistor? Well, clearly I have a magnetic field going through this solenoid. The magnetic field points, well, field lines emerge from north. So the field is pointing that way. Okay? Is that magnetic field getting stronger or weaker? Well, if I'm moving the magnet away, I would suspect the field lines are getting weaker. Fewer field lines will be passing through this. How do I oppose this change? Well, I have field going this way, but it keeps getting weaker. To oppose the change, I would need more field lines going in the same direction in order to try to strengthen it, try to prevent it from becoming weak. So to oppose, I have the field lines pointing that way. All right? If I'm going to have field lines pointing this way, I need to curl my fingers. See, field this way, curl my fingers around the loop. It looks like the current is going down in front. Therefore, it is going to the right in the resistor. Notice, opposing the change doesn't mean you're always opposing the direction of the field. What you are opposing is its tendency to get stronger or its tendency to get weaker. So when you're thinking about this, think about the entire magnetic flux. But but attack it using Lenz's law in terms only of magnetic field. Hope this was helpful.